You're standing in a parking garage at 11 p.m., watching that little charging indicator crawl from 42% to 43%, and you're thinking, did I make a mistake? Remember when filling up your car meant 5 minutes at the pump, not half an hour scrolling through your phone hoping the charger doesn't time out? Yeah, I remember too. Look, we've all heard the pitch. Electric vehicles are the future. Zero emissions, instant torque, whisper-quiet drives. Sounds amazing, right? But here's the thing nobody talks about. If you're renting an apartment, fighting for charging spots with your neighbors, and watching your electric bill shoot up faster than crypto prices in a bull market, that future feels pretty inconvenient. And now that the government pulled that sweet tax credit back in September, you're probably wondering, when exactly does going electric make sense for regular people like us? Well, something interesting just happened. On a random Sunday morning, a certain electric car company dropped a cryptic 9-second clip. No explanation, no flashy presentation. Just shadows, a flicker of light, and one date floating on screen. October 7th, 2025. And suddenly every car enthusiast on the planet sat up a little straighter. Could this be it? The affordable electric car everyone's been waiting for? If you've been following the electric vehicle space for any length of time, you know this moment has been building for nearly 10 years. We're talking about a vehicle designed not for tech nerds or early adopters, but for everyday people. The kind of car that makes electric driving feel as normal and predictable as paying your phone bill. Today, we're breaking down exactly how this upcoming affordable EV could finally crack the code that's kept millions of drivers on the sidelines. And more importantly, how it might quietly change the way every single car, electric or not, gets built from here on out. But real quick, before we get into the technical wizardry, go ahead and smash that subscribe button. Seriously, it helps more than you think, and you definitely don't want to miss what happens when this little car potentially reshapes an entire industry. All right, let's talk manufacturing. Forget everything you think you know about how cars are made. Imagine walking into an automotive factory, but instead of that traditional assembly line you've seen in documentaries, you're watching something completely different. Something that looks more like building with advanced construction blocks than old-school manufacturing. Here's the concept. For over 100 years, cars have been built the same way. You've got this long conveyor belt, right? The vehicle chassis slowly moves down the line while dozens of robots and workers add parts, one after another, in perfect sequence. Sounds efficient until you realize one simple truth. If any single station hits a snag, everything behind it grinds to a halt. The slowest step controls the entire operation. It's like being stuck behind someone doing 40 in a 65 zone. Frustrating, and there's nothing you can do about it. But this new approach throws that entire model out the window. Instead of one long sequential process, the car gets broken down into 6 major modules. The body structure, interior components, battery system, powertrain, windows and glass, and exterior panels. Each section gets assembled separately, all at the same time, like 6 different teams working on different puzzle sections simultaneously. Then, in one carefully choreographed moment, everything comes together. It's almost ceremonial, the way these modules unite into a complete vehicle. Why does this matter? Because bottlenecks simply disappear. Production keeps flowing smoothly instead of constantly waiting for one slow station to catch up. A process that used to consume 10 hours per vehicle now takes roughly half that time, somewhere around 4 to 5 hours. And here's the beautiful part. When you cut the time in half, you also slash the factory space needed. Every square meter of floor space suddenly becomes twice as productive. The result? Manufacturing costs drop by somewhere between 30 to 40% per vehicle. That's not a small improvement. That's revolutionary. But speed isn't the only advantage here. Let's talk precision. Each completed module passes through an advanced scanning gate that uses laser measurement technology. The system creates a digital replica of every part and compares it against the perfect master template, catching microscopic imperfections instantly. What you get are panel gaps tight enough to rival luxury German automakers. Less wind noise leaking through the cabin. Smoother rides with less vibration. Fewer defects that need fixing later. And then there are the castings. You know those massive aluminum pieces you might have heard about? They've evolved into something even more impressive. Instead of stamping and welding together hundreds of individual metal pieces like the old days, the front and rear sections of this vehicle are each formed as single gigantic castings. We're talking about eliminating over 300 separate parts. Thousands of welds just gone. Here's where it gets really clever. These castings aren't just lighter. They're actually designed with built-in crash response zones. The metal structure literally knows where to absorb impact and where to stay rigid when force hits it. It's stronger, lighter, and genuinely smarter engineering. Even the floor panels, which traditionally required multiple metal sheets layered together, now integrate partially with these massive castings. The overall structural rigidity increases by over 15%. That translates directly into better driving feel, tighter steering response, a quieter interior, a safer frame protecting you and your family. For those of us who grew up around classic cars, who remember when vehicles were built with real steel and mechanical soul, this probably sounds like engineering poetry. Because honestly, it kind of is. And here's the compounding effect that makes this so powerful. Faster assembly lowers factory expenses. Better precision means fewer warranty repairs down the road. Lighter components mean you can use smaller batteries while maintaining the same driving range. It's like watching dominoes fall in the best possible way. Every improvement triggers another improvement, creating a ripple effect across the entire automotive industry. But manufacturing efficiency only gets you halfway there. To truly make an affordable electric vehicle, you've got to win the physics game too. So let's pop open the metaphorical hood and look at what's powering this thing. The electric motor takes a fascinating approach. Instead of relying on expensive rare earth magnets, which have been the industry standard, engineers developed a new motor design that eliminates them entirely. It still uses oil cooling to stay compact and efficient, but the magnetic field generation works differently. The result? Torque density improves by about 12%, and the throttle response feels smoother under your foot. No jerky acceleration, no laggy pickup, just instant, linear power delivery. And removing those rare earth elements does something else equally important. Materials like neodymium and dysprosium are some of the most price-volatile commodities on global markets. Their costs swing wildly based on geopolitics and mining regulations. By designing them out of the equation, the company not only cuts expenses but also shields itself from international price manipulation. Then there's the inverter, which is basically the translator between battery and motor. Most competitors brag about full silicon carbide designs these days, which are fantastic for efficiency but crazy expensive. This vehicle uses a hybrid approach. Only the highest voltage, fastest switching stages get the premium silicon carbide treatment. Everything else uses traditional, cheaper silicon components. That single decision cuts silicon carbide usage by roughly 70% while maintaining an absolutely insane 98% efficiency rating. Less heat generation, less energy waste, lower production cost. Now connect that to an 800-volt electrical architecture. Higher voltage means you can deliver the same power with less current flowing through the system. Less current means less electrical resistance, smaller wiring, lighter copper components. Again, lower cost. It's all mathematics, but the effect feels like magic. Charging from 10 to 80% could take just about 20 minutes at a fast charger. And during normal driving, this thing sips electricity like a hybrid, not a power-hungry performance car. Any engineer will tell you efficiency isn't one massive breakthrough. It's hundreds of tiny improvements quietly stacking up until suddenly the scale tips in your favor. And what we're seeing here is that strategy executed beautifully. Now let's talk about the battery, because this is where electric vehicles either become affordable or stay out of reach for most buyers. Instead of traditional wet-coated electrode production, which requires solvents and massive industrial dryers, this uses dry coating technology. The active battery material gets pressed directly onto metal foil and compacted. No toxic solvents, no energy-intensive drying ovens. Production lines become faster, cleaner, and significantly cheaper to operate. The manufacturing footprint shrinks by nearly half. Energy consumption drops 40%. Cost per kilowatt-hour decreases by about 20%. For the base version using lithium iron phosphate chemistry, engineers managed to balance excellent durability with respectable driving range, all while keeping the chemical composition stable across extreme temperature swings. But here's the truly elegant part. The battery pack no longer needs separate module frames and housings. Individual cells get bonded directly into structural chunks that form part of the vehicle's floor pan. This isn't just clever packaging. This is physics transformed into architecture. The battery becomes a load-bearing element. It contributes to the body's overall stiffness. It helps distribute crash forces across the structure. It eliminates unnecessary duplicate materials. The result raises usable energy density by up to 8% while trimming several kilograms of weight, and there's an advanced heat pump system that keeps everything within optimal temperature ranges, whether you're fast charging, cruising down the highway, or parked overnight in freezing weather. The system even captures waste heat from the motor to warm the battery pack, improving cold weather efficiency by roughly 10%. For those of us who value mechanical reliability and proven durability, these aren't just impressive numbers. They're genuine reassurance that electric vehicles are finally becoming dependable long-term transportation. But here's where things get really interesting. Let's talk about what truly separates this company from traditional automakers, and why this affordable model might outlast its competitors long after the hardware specifications stop mattering. Software. Unlike virtually every other car manufacturer, the real innovation here doesn't flow through steel, aluminum, or even batteries. It flows through code. This upcoming vehicle will likely showcase the latest vision-only autonomous system. No radar units, no expensive laser sensors. Just cameras, neural networks, and an absolutely massive training database. The upgraded perception system doesn't simply process images, it understands them. Using advanced video transformer technology, it comprehends the full three-dimensional environment surrounding the vehicle in real time. Pedestrians, cyclists, shadows, reflections, even the way streetlight glares off wet pavement at night. Everything becomes part of the car's awareness. And because the system learns from the entire fleet of vehicles on the road, each car becomes a teacher for every other one. This is where the technology becomes almost poetic. Every unexpected situation, every hard braking event, every tricky intersection a driver encounters anywhere in the world. Somewhere another vehicle learns from that experience, adapts and shares that knowledge across the network. It's like the car collectively grows wiser alongside its drivers. That's the promise of fleet learning. And through intelligent data selection processes, the system only uploads the rare, genuinely challenging moments that push the boundaries of what it knows. This allows constant evolution without exploding data costs or bandwidth requirements. For owners, it means the car they purchase today will literally drive better 6 months from now. Smoother, safer, more confident, all through wireless updates while it sits in your garage overnight. That's how you transform a $30,000 vehicle into something that feels like an $80,000 luxury machine, not through expensive materials or fancy badges, but through genuine intelligence. Now, let's zoom out and look at the complete picture. Modular manufacturing dramatically reduces factory time and expenses. Massive single-piece castings strengthen and simplify the structure. Rare earth-free motors and hybrid power electronics make the drivetrain cleaner and cheaper. A structural battery pack lightens the vehicle while simultaneously adding range and rigidity. And software continuously refines the driving experience, improving with every mile driven across the entire fleet. Stack all of that together and what you get isn't just a car. It's a blueprint for how vehicles will be manufactured for the next half-century. This isn't only about environmental sustainability. It's about manufacturing sustainability itself. If this strategy succeeds, it could force the entire automotive industry to tear up their playbooks and start fresh. Factories would shrink in size. Supply chains would simplify dramatically. Workers would need training on completely new modular assembly techniques. The barrier separating premium vehicles from affordable ones would start to blur. And for the first time, owning an electric